Hello, welcome to my channel. In this video, I'm gonna solve a practice problem from chapter 3 on vector calculus. So, in this practice exercise problem, we have to determine curl of the following vector fields at specific points. So the first vector field is A, which is in Cartesian coordinate system, which is yz in the direction ax plus 4xy in the direction ay plus y in the direction az, and we have to find the curl at the point 1 minus 2 3, and correspondingly um, the vector field B is in cylindrical coordinate system, which is rho z sine phi in the direction a rho plus 3 rho z square plus cos phi 3 rho z square cos phi a phi in the direction a phi at the point phi pi by 2 1. And the last vector field is in spherical coordinate systems, which is 2r cos theta cos phi in the direction ar plus root over r in the direction a phi. And we have to find the curl at 1 pi by 6 pi by 3. Now, before we get to the problem solving part, we have to understand what curl is. So let me explain um, let me explain curl, then we will go to the problem solving part. So here, curl of a vector is, given a vector A, curl of A is a rotational vector whose magnitude is the maximum circulation of that vector around a point, say point P, per unit area as area tends to 0, and its direction is normal to the surface of the circulation or rotation. and and curl is mathematically represented by curl A, which is equals to vector multiplication of del operator and that vector field, and by definition it is expressed like this: the uh, closed line integral of that vector divided by differential surface as surface tends to 0. This integration is a vector, and um, it directs to the normal to the surface in which the vector is rotating. So this is the full mathematical expression. We are going to use this mathematical expression to solve our problems about curls. And in summary, curl is a vector. In summary, curl of a vector is another vector, a rotating one. Curl measures how much vector field rotates around a point P, say, and curl is used to determine if a vector is rotational or irrotational. So irrotational field is also a conservative field. So I made a mistake problem in my previous problem solving video in divergence, where I pointed out that divergence is used to um, determine if a vector is conservative or not. That was a mistake. We use curl to determine if a vector is conservative or not. So that was a mistake for me. So, and that's it. We're gonna get to the problem solving part. So before getting the problem solving part, we're gonna see what uh, vector multiplication of del and the vector field um, uh, is expressed in the three coordinate systems. So here these are the three curl operations in the three coordinate systems. So this is the curl operation in Cartesian system, this is curl operation in cylindrical system, and this is curl operation in spherical coordinate system. Now we're just gonna directly use these uh, formulas and get the value. So let's get started with the problem solving part. So this is our first vector field, And to get the curl, this is in Cartesian system or rectangular system, so vector multiplication with del operator, which is ax, ay, az, partial differentiation with respect to x, partial differentiation with respect to y, partial differentiation with z. Now yz for xy and y, so this is partial differentiation with respect to y minus del z for xy, ax minus partial differentiation y minus partial differentiation z, yz, ay plus partial differentiation with respect to s, x for xy, partial differentiation with respect to y, yz, az. Now just doing the partial differentiation, so this becomes 0 because there's no z, and this is 1, so 1 ax, now minus, so here 0 and this is y, so minus y ay plus here 4y minus, so this is 4y minus z in the direction az. Now this is the curl ax plus y ay plus 4y minus z az. So we have found our curl, which is also a vector, and now we find this curl at the point. So ax plus minus 2 ay plus 4y minus 8 minus 3 az. This is ax minus 2y minus 11 az, and that's the answer. So this is our second vector field, and its corresponding components. We have to find curl at this point. So vector multiplication with del operator, a rho 1 by rho a phi az cos phi and 0. So 1 by rho, so 0 minus del by partial differentiation with respect to z, 3 rho square z square. So here this component in this vector multiplication will be rho b phi. So b phi is 3 rho z square cos phi, and multiplied by rho is 3 rho square z square cos phi. So 3 rho square z square. So here again 0 minus partial differentiation with respect to z, rho z sin phi in the direction rho a phi. So then plus for this az in the direction az, so partial differentiation with respect to rho, 3 rho square z square cos phi minus differentiation with the partial differentiation with respect to phi, rho z sine phi in the direction az. Now I'll just write this. So partial differentiation with respect to z is 6 minus 6 rho square z cos phi in the direction arrow minus and minus plus. Partial differentiation with respect to z is um, rho square sine phi in the direction a phi, rho square sine phi in the direction a phi plus, so this will be in the bracket. So inside the bracket, so 6 rho 6 rho z square cos phi minus here rho z cos phi the direction az. So there is also 1 by rho. So if you take the 1 by rho inside the brackets, it will give us minus 6 rho z cos phi a rho plus rho sin phi a phi plus 6 z square cos phi minus z cos phi ez. So this is the curl of the corresponding vector b in cylindrical system. Now at the point 5 pi by 2 1, so this at 5 pi by 2 1, so here minus 6 cross 5 dot 1 cos pi by 2 arrow plus 5 sin pi by 2 fi plus 6 dot 1 square dot cos pi by 2 minus 1 dot cos pi by 2 az, which is this is 0, this is 0, so leaving behind sin pi by 2 is 1, so 5 a phi. That's the answer. This is our third and last vector field, which is in spherical coordinate system. We have to find curl in spherical coordinate system at the point of this vector. So del operator vector multiplied with the vector c, which is in spherical coordinate system, so the formula is ar a theta r sine theta a phi, and there is 1 by r square sine theta. So now I'm gonna, this will take long time, so I'm gonna do it in very short and straightforward way. Not gonna write any extra lines. So this will give us, say, 1 by r square sine theta. So but this is root r, so partial differentiation with respect to theta r 3 by 2 sine theta, direction ar minus, so here del r, so r 3 by 2 sine theta minus partial differentiation with respect to phi 2r cos theta cos phi r a theta plus so minus, so here is 0 and this, so partial differentiation with respect to theta 2r cos theta cos phi in the direction r sin theta a phi. So if we take the, okay, so 1 by r square sin theta, and here is r 3 by 2 minus, so r 3 by 2 cos phi, so partial differentiation with respect to partial differentiation of sin theta with respect to theta is cos theta plus cos theta, so here 3 by 2 uh, minus 1, so half sin theta minus minus and minus plus 2r 2r cos theta sin phi, here partial differentiation with respect to phi r a theta plus, so plus partial differentiation of cos theta with respect to theta is sin minus sin theta, so minus minus plus 2r sin theta, so sin theta cos phi r sin theta a phi. So if we take the 1 by r square sin theta inside the brackets, it will give us, so this is 1 by root r, and cos by sine is cot theta a r minus, so 3 by 2 1 by r 3 by 2, and sine cuts out, plus 2 by r and cot theta sin phi, and here is also r, so if we, so here's also r, and here's r 3 by 2, and here's r square, so it will give us, so 3 by 2 root r plus, so r square, so 2 cot theta sin phi ar plus, so r sin theta, so here r square sin theta, so 2 sin theta cos phi a phi. So this is the curl of the vector c, which is in spherical coordinate system. Now we find curl at this point. So this is the curl of the vector c, which is in spherical coordinate system. Now all we have to do is find curl at this point. So this is the curl, 1 by root r cot theta in the direction ar minus 3 by 2 uh, 1 by root r plus 2 cot theta sin phi in the direction a theta. Okay, a theta. So a theta plus 2 sin theta cos phi in the direction a phi. So curl at point 1 pi by 6 pi by 3 is, so substituting the values in the curl. So root 3, so cot pi by 6 is root 3 in the direction ar minus, so here this will give us, so this is, so this is 9 by 2 a theta plus, and this is 1 by 2 a phi. So this is the answer. So that's it. Thank you for watching my videos this far. I hope you understood my explanation and the calculation for the curl at points in the respective coordinate systems.